friends, welcome back. In this tutorial we will study about OSI model. The full form of OSI is Open Systems Interconnection. So in this tutorial we will study about Open Systems Interconnection model. Now what happens? The OSI model is a model for understanding and designing a network architecture which is flexible, robust and interoperable. The OSI model is a layered framework for the design of network systems which allows communication between all types of computer systems. It consists of 7 layers. As you can see here in this diagram, physical layer is the layer 1, data link layer is the layer 2, network layer is layer 3, transport layer it is layer 4, session layer it is layer 5, presentation layer it is layer 6, application layer it is layer 7. Now in the process of transmitting data, many networking functions are involved. So in this OSI model, the networking functions with related uses are collected into separate layers. Each layer defines a family of functions which is distinct from those of others. The OSI model allows complete interoperability between otherwise incompatible systems. Within a single machine, each layer uses the services of the layer just below it. There is an interface between each pair of adjacent layers, and each interface must define the information and services a layer must provide for the layer above it. Now what happens between the machines? Layer X of one machine communicates with layer X of another machine, and this communication is governed by protocols. Now let us see the working of this OSI model, right? Now see this diagram. Suppose here device A is sender and device B is receiver. Now let us see how this device A sends a message to device B. So what happens? The process starts at layer 7, which is the application layer of device A, right? Here device A is the sender, right? So what happens? The process starts at application layer of device A, right? And then what happens? The data unit must move down through the layers on device A, right? So what happens? The data and network information pass down through the layers of the sending device, right? And at each layer a header or possibly a trailer can be added to the data unit. Commonly the trailer is added only at layer 2, that is data link layer, right? And when this formatted data unit passes through the physical layer, it is changed into electromagnetic signal and transported along a physical link, right? So when it reach the device B, the signal passes into layer 1 and it is transformed back into digital form, right? And then data unit moves back up through the OSI layers, right? So what happens? Upon reaching the device B, which is the destination, the signal passes into layer 1 and it is transformed back into digital form, right? And after that the data unit moves back up through the OSI layers in device B, right? So what happens as each block of data reaches the next higher layer, the headers and trailers attached to it at the corresponding sending layer are removed, right? And the actions appropriate to the layer are taken, right? So when it reaches layer 7, the message is again in appropriate form to the application and it is made available to the recipient, right? So as a message travels from device A to device B, it may pass through many intermediate nodes, right? And these intermediate nodes usually involve only the first 3 layers of OSI model, that is physical layer, data link layer and network layer, right? Now these layers, layer 1, layer 2 and layer 3, right? These are network support layers. They deal with physical aspects of moving the data from one device to another, right? layer 5, layer 6 and layer 7. They can be considered as user support layers. They allow interoperability among unrelated software systems. Now this layer 4, which is the transport layer, it links these two subgroups, right? And it ensures what the lower layers have transmitted, it should be in a form that the upper layers can use. The upper OSI layers are almost always implemented in software. Lower layers are a combination of hardware and software, except the physical layer, which is mostly hardware, right?